My name is Gülink, and today I want to present to you the Smile microLED platforms as customer-centric display solutions. And in the beginning, let me firstly introduce shortly QubeDot. We were founded in 2019 based on 45 personal years of development with a unique technology to process the gallium nitride material system. And we're a passionate team of around 15 employees at the moment. And the difference from our view to the big players is that big players, they do not touch their standard processes, and we do offer customized and standardized products in this case. And we're safe to provide designs from 1 micron to 1000 micron. So it's not only micro-LEDs itself. Let's have a look at very first smart platforms with the monolithic approach. These products are kind of the first step into the door products. We offer 16 by 16 micro-LED arrays with a standardized contact ring and different pixel sizes of the emitting array. These platforms have a frame rate, a real frame rate of 170 kilohertz. And most of the time they give a very first impression of what micro-LED technology can actually do. And then there are other systems with, for example, 8x8 pixels that can be modulated pretty fast. In this case here, and 5 micron pixel, 5 micron gap, so 10 micron pitch, 8x8 array modulated with 1 kilohertz from pixel to pixel to pixel. The gallium nitride material system, of course, works best in the UV to green range. But nowadays, we have also tweaked our epitaxy in a way that we can offer a decent red emission, of course, at lower efficiencies, and a small shift from red to like orange that's possible via the current density. As you can see here also on the images, these red micro-LEDs have feature sizes down to 3 micron, and you can see a lot of different shapes and forms that are possible. The wavelength is tunable and it can be adapted to customer designs. I want to stress again that how we process micro-LEDs itself, that the pixel form is rather size independent. And for this, I want to show some impressions on this slide. So the pixel doesn't have to be round or square, like you can see on the left side of the images. A pixel on our side, it can also be a complete sign or the letter itself. For example, on the bottom right, you can see this, that the QubeDot logo itself is just like 1 pixel that can be, for example, useful for information displays. Our technology also allows us to produce quite some interesting aspect ratios. So on the top right, you see a micro-LED line array where each line is 7 micrometer thin, but 5,000 micrometer long. So that is also for some use cases very interesting. And like I shortly said, an example might be information displays, where in the off axis you want to provide information at a scale where you already know, okay, there will be a battery sign or there will be a lightning sign. You do not need to have a completely integrated micro-LED display over there. You can just have an information display where the pixel is the sign you want to showcase anyway. I want to move now a little bit big to general assembled displays. On this slide, once we agree with Joel, if you want to make micro-LEDs successful, you have to reach high efficiencies at the single-digit diameter regime in micrometers, and you need a transfer with a very high yield to make the step from prototype to product. And I'm pretty sure that after my presentation, Oliver Haupt will talk a little bit about it. So, as I said, we at QubeDot produce micro-LEDs, and we bump them, and we bump the backplane, and we do the transfer with the tools available from our transfer toolbox. And as you know, all the calculations, even if you have a transfer yield of 99.99% on a 4K display, that still means that you have 2,500 dead pixels, and that's not acceptable on a customer level. So good micro-LEDs on wafer level are nothing without a proper transfer and the correct interconnection technology. And that's why we as well perform laser lift-off after bonding or laser-induced forward transfer for the direct micro-LED transfer and bond. One other important point that I really want to stress today is that at the moment, there's no golden way in the micro-LED industry. Every company and at every stage works on their kind of own micro-LEDs and try to come to the solution. And we also offer this customized solution. And for different use cases, the customer also might some different brightnesses and emitter solutions, that's clear. However, standards regarding die size, contact sizes, and emitters have huge benefits at the interfaces of all the industry partners. And these standards are not there yet, at least I do not see them. So we at QubeDot, we do offer our customized micro-LED solutions, but we do also offer standardized solutions. And like, for example, here on the bottom part of the page, you can see die sizes of 80 times 80 microns, so like rather mini LEDs with different contact pad configurations that are ready to transfer. How does this look now a little bit more in detail? For example, if we assume dies with 14 times 14 micron, like on the left side, we can produce wafers with these micro-LED dies, and we can pre-bump them on the wafer. And I think from this type of die, like on a 6-inch wafer, there should be like around 150 million LED dies, roughly around this. I think more interesting is on the right side, the zoom in on the SEM image where you can actually see that like contact forming is possible here with these triangle shapes. And this is something that we offer. Nowadays, they're always customer specific. And I said that like LED solutions without a transfer are nothing. And just to showcase this, we do transfer them successfully, in my opinion. These are the same dies that we have seen on the slide before. So on the left side, you can see several cross sections from the focused ion beam, showcasing that we have rather defect-free interconnects at this part. And on the right side, you can see the small gap after the transfer that most part of your display, if you would bump your display with this type of die, that the fill factor is high. Of course, for example, in the case of UV, beforehand, when you want to do a transparent micro-LED display, you would just choose a higher gap between the LEDs after transfer. That's feasible on this part. So we at QubeDot, we deliver your micro-LED mostly again on Sapphire solution. We do this on our customized, on a customized basis, but we also do this on standardized die geometries that are directly and faster available. And the limits of this process, of the standardization process, are given here relative to the die size on this slide. And I also want to express again that after we have identified together with our customer and the interested parties the correct die size and emitter size and contact configuration, we do perform partly also the transfer with our transfer toolbox. And that's mainly it. Thank you for listening. And if you want to contact me, yeah, are the information.
Thank you, Jan. Thank you very much. Any question for Jan, please? Raise your hand. Jan, what are the key markets segments you are targeting with your customizable, technology?
Yeah, so the most important market for us is actually light engine development for augmented reality of companies that cannot be named yet and is like under NDAs. We do also produce micro LEDs for metrology, especially when you have very defined point sources, and for microscopy, for example, and for sensors. But also main driver for us is the display market.
Okay. And is this process longer than a normal process, and if yes, how much is it longer?
Sorry, can you repeat that question again? I did not fully grasp it.
Is your process you are developing is longer than a usual process, you know?
In comparison to what process? Of course, we have not so many mask layers, so we're always faster than the CMOS industry, and we can adapt more quickly our light sources, for example, to CMOS backplanes, where feedback loops are way longer. That's definitely a plus on the versatility side. And of course, we can produce wafers and use them on several different backplanes, especially if we reach a higher degree of standardization. I hope this covered the question.
Yeah, thank you. Yeah, any question? Okay, so thank you again. And just for you to know that we'll organize an epic meeting at Photonics next year in June. And it will cover all the augmented reality topics. So, and we will have a session really dedicated to display and you know, display technology. So it could interest you.
Perfect. Sounds like a good fit. Thank you.
Exactly. So thank you, Jan, again for your nice presentation. And now we welcome Oliver Opt. Oliver, you are Director of Strategic Marketing for Display Capital Equipment at Coherent. So Oliver, if you are here, you can start sharing your screen and start your presentation.
Of course, I'm here. Thank you. Yeah, I think there, for you, the French guy, the names are not so easy, right? Can you see my screen now?
Perfect. You can start.
Yeah.